In the last video, we looked at some basic work with vectors. In this video, we're going to do some exam style questions. If you haven't seen video 1, please check that out as it's got some key learning points in. In this question, we're told OABC is a square. The vector OA is equal to A, the vector OC is equal to B. Point D cuts the line AB in the ratio of 2 to 1. In part A, we need to find, in terms of A and B, the vector that represents AD. In part B, it says if point E is halfway along BC, find the vector that represents DE. And then finally in part C, using your answers to parts A and B, show that the vector OE is represented by B plus 1/2 A. Whenever I get a question like this, I like to go through the whole part right here, the whole question, and then simply go ahead and write down all of the vectors that I can add to this diagram. So let's start off. OC is B. That must mean that AB is also B. This is a square, so it's going to have equal length and the same direction. So same magnitude, and it will be parallel. So we're told now that point D cuts the line AB in the ratio of 2 to 1. That means that we got 3 equal parts. So 2 to 1 ratio, 3 equal parts. Now this whole length here is going to be the same as this one and in the same direction. So we can say now that this would be 1/3 B. So D to B is going to be 1/3 B. Therefore we can say A to D will be equal to 2/3 B. Generally when we're doing this we can write now a vector in our own handwriting with a little line underneath. In the book or the exam they'll be bolded. We often write a little line underneath. I'm going to exclude them as I'm kind of running out of space. Now I'm going to write this out. What I'm going to do is just write here now the following. We can say that the vector AD, and I'll write it just here, will be equal to 2/3 of the vector now AB. That's a formal approach. I can simply write that AD is going to be equal to 2/3 now B. And that's the first bit done. So I've written it like this as later on we might see some scenarios where we need to write this out. Okay, so if now point E is halfway along BC, okay, so let's first do that bit. So it's halfway along. Now we know that the vector OA is A, therefore the vector CB is A. If E cuts this in half, I can put with the correct direction, this is 1/2 A, and this is 1/2 A. So that's what I've got on there. We need to find now a vector that represents DE. So let's build up that journey. I can go from D to B and B to E. So I can write on here now D to E will be equal to D to B plus now B to E. So let's go ahead and do that. We can say now D to E will be D to B, which is 1/3 B. Now, we need to be careful here. We're going against this vector. We're going in the opposite direction, so that's going to be minus 1/2 A. A common error is for students to put that's 1/2 A. These have both magnitude and direction. So if we said now that E to B is 1/2 A, B to E is minus 1/2 A. Okay, so that's the vector now D to E. In part C it says, using your answers to parts A and B, show that the vector OE is represented by B plus 1/2 A. Well, quite clearly we can see that we could go from O to C and C to E, but we need to use our parts A and B. So what we can say then is O to E could be built up with the journey now, O to A, which we're given in the question, plus now A to D, which we found out, plus now D to E, which we also found out. So we need to use this now in the part here. So we've got O to A, which is given to be A. We can see that, we're told that. A to D is the part that we found, which was 2/3 B. And then we got D to E, which is plus now 1/3 B minus 1/2 A. So if we consider now 2/3 B plus 1/3 B is B, A minus 1/2 A is going to give us plus 1/2 A. So we can see that is the resultant vector. Now we could have, as stated, done this. I could have gone across here and then up like so. And that would have given me now the same resultant vector as what I've just done. I've gone now up this way and I've gone across and I've come down. And that's ended up now in this displacement vector, i.e. now the position relative to the origin being exactly the same. Vectors are not about the distance travelled, they're simply about now the position relative to the origin. So if we put this now, and this would be the vector, let's say that's C. So we could say that OE would now be the vector C, and we could make that up different ways. I can go OCE, or I can go O to A to D, D to B, and B to E, now given what I've built up in the previous part. But generally, if we weren't asked to do that, I'd say OCE, given the properties of a square. Okay, OABC is a rhombus with OA represented by B and OC represented by A. We're asked in part A, what is the vector OB represented by? Part B, what vector represents OP if point P divides the line OB in the ratio of 1 to 2? We're told point Q divides the line CB in the ratio of 1 to 2. What vector represents CQ? And in part D, we need to show that the line PQ is parallel to the line AB. Okay, let's go ahead and label some stuff up. OC is A, therefore AB is also going to be A. This is a rhombus, so we're going to have now equal magnitude or length and direction. So this is parallel. So what we want then is OB, and I can write this like so. I can write OB will be equal now to OA plus AB. So the formal approach, we can write that, or simply write down now A plus B. So all I've done is written that there. So now let's write O to B will simply now be A plus B. I prefer to write it in alphabetical order, or if we got a negative, write the negative second. So if this was, for example, minus A plus B, I'd like to see it as B minus A. Doesn't matter though, you'll be given the same marks regardless. Okay, what vector represents OP if the point P divides the line OB in a ratio of 1 to 2? So again, what we've got here now is this line split into 3. So we've got this split into 3 equal parts. So what I can now say, putting the direction on, this is going to be 1/3 of the way from O to B. Now we know that O to B is A plus B. So I can say that's 1/3, and then again, with this direction, this is going to be 2/3, and then we'll have A plus B. So what I can do formally, if I want to write this down, I can say now that OP will be equal now to 1/3, and then let's just, don't need that, 1/3 the vector OB. So let's just do that. Let's write that out first rather than put it in brackets. We can have 1/3 now OB. So therefore we can say that this is 1/3 A plus B. The reason I like to put these in brackets like so is that in some questions we might ask to show now parallel lines. A line parallel to this, or vector parallel, will be some multiple of A plus B. It will be some multiple of A plus B. So just be aware that if you factor these, it's often easier to find a parallel vector. Okay, point Q divides the line CB in the ratio of 1 to 2. We need to now find out what vector represents C to Q. So again, this is splitting this up into 3 parts. 1 to 2 ratio means that there are going to be 3 parts. So this right here, consider that OA is B. This now is going to be 1/3 B, and this is going to be 2/3 B. So we can simply state now that C to Q is going to be 1/3 B, and that is because we've got a rhombus and OA is of equal length and direction as CB, they're parallel. Okay, that's fine. We now need to show that the line PQ is parallel to the line AB. So if we consider now, and I'll write this out, AB is just A. So we can write here now AB, so AB is equal to A. What I want is some multiple of A. If it's parallel, it will be some multiple of A. So let's go ahead and look at PQ. With PQ, I can do lots of things. Building up a vector journey, I can go from P to O. I can go now from O to C, and I can go from C to Q. So all I'm going to do is build this up. Now I know what O to P is, and in general what we can say now is P to O will be equal to minus O to P. So what I can now write is the following. P to Q will be equal to P to O. So P to O is going to be minus, and I'll expand the brackets, minus 1/3 A minus 1/3 B. O to C we can see is A, so we're going to plus A, and then we know that C to Q is plus 1/3 B. So let's go ahead and look at that. Now from here it seems that my B's are going to cancel. I've got minus 1/3 B plus 1/3 B, which is going to cancel. So I can say now the following. I can say that the vector PQ, so vector journey for PQ, is going to be 1/3 A plus A, which is 2/3 A. Therefore, now I can state on here, and this is a formal approach, we can say now that AB, the vector AB, is going to be equal to 3 over 2 PQ. And we can say now parallel. They're parallel. It's just some now scalar multiple. And the scalar is just a multiplied up version of a line in the same direction. Now, if we didn't have something as A and we had A plus B, we would be looking for some expression that we could factor as a multiple of A plus B. Okay, let's look at another one. In the parallelogram OABC, point Y cuts the line OB in the ratio 5 to 1. Point X cuts the line AC in the ratio of 5 to 1 also. Write down in terms of A and B, AOB, YYB, CAC, DXC and EXY. In part F, we need to state what is the geometric relationship between lines X, Y and CB. Okay, let's go ahead and label some of this up. Parallelogram, that means that AB is going to be equal to B. We know that. If this now is here and OC is B, this is both parallel and of equal length or magnitude. BC is going to be A. Again, CB is going to be A as OA is A. So let's consider what we've got right here. What I can say from this now is the following. I've got O to Y and this now is in a ratio of 5 to 1. So I can say the following. I can say that the vector OY will be equal to 5/6 now of the vector OB. It's 5/6 of the wave there. So what we can say from this then is the vector OY is going to be, now if I want to go from O to B, I need A plus B. So we can say that this is going to be 5/6 A plus B. That now gives me OY. Now let's consider what I want right here. If I look at AC, I know that X is 5/6 of the wave there as it's split in a 5 to 1 ratio. So what we can say then is the following. On here I can say A to C, and I'll write it just here. So A to X is going to be equal now to 5/6 of A to C. And I'm just building these up as I go. I'll go on to answer the questions as we roll from here. So what we've got then is AX is 5/6 of AC. So if I want to go from A to C, it's going to be minus B plus A. So I can say now that AX is going to be now 5/6 of B minus A. So that's just building those up. So let's go ahead and answer the questions. OB, quite clearly, we've just found that. OB is going to be now A plus B. So OB, as we've just seen, is going to be A plus B. Okay, we want Y to B. Well, Y to B is going to be 1/6 of it. So what we can say now is the following. We can say that Y to B is going to be 1/6 A plus B. And that just gives us now this little part right here. Okay, A to C, well, we've just seen that A to C is going to now be, from here, A to C is going to be B minus A. So A to C is going to be now B minus A. We've done that one. We want X to C. Well, we've just seen now from at X to C is going to be 1/6 of this. So we can say X to C is going to be 1/6. Now, A to C, we can say then X to C is going to be 1/6 for quantity B minus A. I've kind of done this a back way round rather than answering the questions, but essentially you can see how this can be done. Okay, what we want now is X to Y, and there are lots of different approaches for this. The way that I'm going to do this now is say that X to Y can now be equal to X to C plus C to B now plus B to Y, and this is one of the many ways around you can do it. So what we can say then is X to Y is going to be equal now. I'm going from X to C, which I know is going to be 1/6 B minus 1/6 A plus now C to B, which is going to be plus A plus B to Y. Now we already know what Y to B is, so if I want B to Y, it's going to be minus this value. So it's going to be now minus 1/6 A minus 1/6 B. Okay, so that's what we have. So what have we got? We've got 1/6B minus 1/6B, which is going to be 0. 1/6 minus 1/6A minus another 1/6A, which is going to be 1/3 A, plus a, which is going to give me now x to y is going to be 1/3 a minus 1/3 a from a, which is going to be equal to 2/3 a. So all I've done is built that up. If I just show now what those terms are, we've got now 1/6b minus 1/6b, which gives us 0. We've got now on the other ones, we've got here, now we've got minus 1/6a, minus 1/6a, which is 1/3 a, and we've subtracted that from a, which gives us 2/3 a. So what are we now saying? The relationship between C and B? Well, we can see now the following. We can see that CB, and let's just write this here, CB is given to BA. We can see that XY is 2/3 A, so what we can say then is the following. We can say that CB is going to be equal to 3/2 XY, so this is 1.5 times longer and it's parallel. So we can say 1.5 times longer, and also parallel. So they are two things that we can say about that by simply now finding the vector journeys. Okay, let's do one final question. ABCD is a trapezium with BC parallel to AD and 3/4 of its length. So here's BC and here's AD. AD is equal to 12b, DC is equal to 6a. Point E cuts the line AC in the ratio 5:1. We need to find in terms of A and B, AC, DE and AB. So straight off now I want to write now that B to C is going to be 9b. So let's grab up a pen that's not white, that doesn't look too good. This right here is going to be now 9b. It is simply now 3/4 of the length of AD, and as it's parallel it's going to be now in the same direction. Okay, we've got the point E cuts the line AC in the ratio of 5:1. So what we want to do now is first find AC. AC is going to be straightforward. AC, and I'll write it just here, AC will be equal to AD plus now D to C. And we've got those journeys there, so nice and straightforward. A to C is going to be equal to 12b plus 6a. Now I'm going to factor this, and I'm going to write this as 6, and then we're going to have 2b plus a. So that now is the vector AC. Okay, now point E cuts the line AC in the ratio of 5:1. What we want to find now is D to E. So what I'm going to look at now is just to begin with AE and EC. So if I do that now I know that this cuts it into 6 parts. Therefore, the vector AE is going to be 5 lots of 2b plus a. And this is going to be 1 lot of 2b plus a. That is cutting that line now into 6 parts. We know that A to C is 6 lots of 2a plus b. So if this is in a ratio now of 5:1, it's 5 6s and 1 6. 5 6s of this is going to simply give me 5 lots of 2a plus b. You certainly don't have to factor that. I just personally think factoring it makes it slightly easier. So what we want to do is go now from D to E. And I've got lots of choices here. What I'm going to do with this one, and we can write it on, we can say now that D to E, so D to E, just looking at this, I can go now from D to A plus now A to E, and that's one of my choices. I could have gone from D to C and then gone from C to E. So what I'm going to write then, D to E, the vector that's going to represent that, D to E is going to be D to A. So that's going to be minus 12b, plus now, if I consider I'm adding this one, that's going to be expanding this, we're going to have 10b plus 5a. So what does that leave me? That leaves me 5a minus 2b. So that's what we end up with, and nice and straightforward. Okay, we now need to find A to B. So with this one, this should be fairly okay. We can simply say but A to B, and you can go any way round on this. You can go from A to C, which we've already got, or then B to C, or you can go right the way round the other way. I'm going to go right the way round, as it's neither here nor there. We will get the same answer. So what we'll have then is A to D plus D to C plus now C to B. So what's that going to give me? A to D is going to give me 12b plus now D to C, which is going to give me 6a, plus C to B, which is going to give me minus 9b. So we can see from here that we're going to end up now with 3b plus 6a, or if we like 3, the quantity b plus 2a. And of course, you can do that any which way you like by going based on the vectors that we've already found. We found a to c, and then we can simply go back this way from there. So the reason I did that is to give you another option. So there we go, some work with vectors, looking now at a range of different exam style questions that you might end up having. I do suggest that if you can factor things, try and factor things, especially if you see the word parallel somewhere in the question.